Alright, this is my second video on solving logarithmic equations. So this problem's going to be a little bit longer. That's why I have its own video for it. So we're going to solve the equation. When we're done, we're going to check our solutions. So I have log base 2 of x plus 2 plus log base 2 of x equals 3. So I do have two logs here with the same base, but one log and the other log, they're both on the same side of the equal sign. So you can't use that property where, if the log is equal to another log with the same base, then we can say they're equal to each other. But we are going to use some of our properties with logs. The important thing there is this plus sign right here. So currently we have two logs, and remember, when you have two logs of the same base added together, we can condense these by multiplying them together. So think of our properties of logs where we can condense. So we're going to go from two logs condensed down to one. So I'm going to have a log base 2, but this time I'm going to have x plus 2 times the x from the other piece. So I went from 2 logs down to 1, and this is still equal to 3. Now before I move on, what I would do is clean up a little bit of this inside here that, two things multiply together. So I'm going to take this x times x and this plus 2 times x. So really we're dealing with log base 2 of x squared plus 2x is equal to 3. So this is very similar setup to some of our problems. The second problem in the solving log equations 1 video. So I have my x here, a log with it is equal to 3. So we're trying to solve for x. We want to get x all by itself. So to get rid of this log base 2, we're going to take this base 2 and raise everything else as an exponent to base 2. But if I do it to one side, I have to do it to the other. So this is 2, a base, raised to the exponent log base 2 of x squared plus 2x. And on the right side, I have 2 to the exponent 3. The reason why we can do this and why it's important to us is the inverse properties of log says the two bases there are the same, so they are inverse operations. So we have x squared plus 2x is equal to 2 to the third power, which is 2 times 2 times 2, which is 8. So what I have here is I have x squared plus 2x is equal to 8. Now typically we're still solving for x. When I see an x squared, I'm immediately thinking we're going to have to solve this by factoring. So to do that, I'm going to subtract 8 from both sides because I want to get this equal to 0, which allows me to solve by factoring. Now the key piece here is, notice how I have a 1 in front of the x squared. That makes this very easy to factor. I'm looking for two numbers that multiply to negative 8, but add to positive 2. Multiply to negative 8, add to 2. Two numbers that multiply to negative 8, add to 2. So those two numbers hopefully don't take long to think about. It's going to be x plus 4 is one of my factors, so positive 4 is one of my numbers, and negative 2 is my other number. So x plus 4 and x minus 2 is equal to 0. So I have it factored. The only thing left to do is set each of the factors equal to 0 and solve. So x plus 4 is equal to 0 and x minus 2 is equal to 0. So solving the left one, I get x is negative 4, and of course that's by subtracting 4 to both sides. And my right one, I would add 2 and add 2, so I get x equals 2. So I have two answers here, x equals negative 4 and x equals 2. But I'm not quite done because I do have to plug back into the beginning to check our solutions. So I'm going to check each of them individually. What I'm going to do is I'm going to take negative 4 and plug it in for all of my x's in the beginning. And what I'm going to do is simplify and make sure I get some number equals that same number. So this would look like log base 2 of negative 4 plus 2 plus log base 2 of negative 4 equals 3. Now that would simplify to log base 2 of negative 2 plus log base 2 of negative 4 equals 3. Now I simplified it as far as I could go. What I would do here is figure out these equivalent numbers in a calculator. So you could do that by doing the change of base formula and say, what is log base 2 divided by log of 2? So the negative 2 on top, the positive 2 on bottom. So if I go to my calculator and type, log of negative 2 divided by log of 2, when you enter that in, you're going to get this error. It says error non-real answer. What that means is we cannot calculate this. So the calculator is saying we're having an error. So what that means is this x equals negative 4 is not a solution. In fact, it's what we call an extraneous solution. So when I'm reporting my answers for this, x equals negative 4 is not a solution. This is why checking your answers is super, super important. But I don't want to just assume that means x equals 2 is going to work. We want to make sure to plug it in, check, and make sure it works. So I'm going to still have log base 2. So I'm just plugging in 2 back into my original equation. So substituting in for x. So log base 2 of 2 plus 2 plus log base 2 of 2 equals 3. So that's log base 2 of 4 plus log base 2 of 2 equals 3. So I'm kind of in the same predicament I was on the last time. I would again try and find what those equivalents are. So I do log of 4 divided by log of 2. I'm going to figure out log of 2 divided by log of 2 and see, hey, does this in fact equal 3? So here we go. Here's log of 4 divided by log of 2. So using the change of base. And I got 2 for this first piece. And then I have to do log of 2 divided by log of 2, which for some of you that might be obvious. We'll have the same thing on top and bottom that should divide 1. But just in case, there you go. It is in fact 1. So I have 2 plus 1 on the left side, and this is supposed to be equal to 3. Well, hopefully we realize at this point, well, 2 plus 1 is 3. So I'm kind of running out of room there. I get 3 equals 3, which is our answer that we wanted. So it's kind of hard to see there with the camera, but I did in fact plug in, figured out these values, and so I got 3 equals 3. So that tells me x equals 2 is my solution to this problem. And that was solving logarithmic equations, my second video.